Mhm. Good evening, guys. Hello. Are you audible?
Yes, sir.
Am I audible?
Good evening,
Yes,
sir.
yes. And my screen is also visible, right? I'm sharing my screen. So actually, today is the last week of the session. And however, I also planned an extra session of 2 hours by tomorrow, 6:30 to 8:30. Please join. We'll be discussing if you guys have any problems or regarding any understanding issue, any understanding if you understand, we'll be discussing along with we'll be discussing the that multiple choice questions that I've already told promised before we have started our session at the beginning of our session. Uh, and I am planning that the tomorrow class will be dedicated to only that. So today we'll be doing as before that we have done already this in the past weeks, and similarly we'll be doing in this session also. We're doing solve problem solvings and also and assignment problems. Along with, I'll try to finish some part of the questions regarding the MCQs if positive time permits. Otherwise, the tomorrow 6:30 to 8:30 p.m. we'll be discussing those questions. So I have planned that way. Okay, so please kindly join in the tomorrow session. It will be productive, I think. So today, I think only these the two of you are there. I think no one will be joining today. Is there any input or is there any information that others are joining? Lalita, Abdul, can you confirm?
Yes, sir. Okay, sir. I will be available.
Okay. So we can start our session today. I think is we should start. So today we'll be discussing the assignment problem first. Then we'll be going through some detail about this today's lectures and this week's lectures. Actually, this week lectures covers self-compacting concrete. It comes under special category concrete. The various tests that confirms its suitability as the self-compacting. This confirm is self-compactability. There's also several tests uh, also exist. We'll be discussing one by one, and also there's a mixed proportioning, and also there is a fiber input concrete. How this fiber randomly oriented, either randomly oriented or aligned gives improvement or improves the performance of the concrete in under flexural bending. So we'll be discussing these things, and also how um, these fibers, if the fire for the uh, short and um, uh, short fibers, long and short fibers will be there's a many equations that identify the stress characteristics. What is the stress are coming to the concrete matrix, the concrete system. We'll be discussing that, and also we'll be finding the crack spacing aligned for aligned and also for short fibers. Okay, and also the lastly some and also there are also a few points that relates to the workability of this fiber reinforced concrete. There's also we'll be discussing, and then lastly, this roller compacted concrete will be discussing, and in the last lecture that Professor Bhattacharya has explained that regarding the polymer concrete composites. Polymer concrete composites, polymer integrated composites, heavy concrete, where the usage of those concrete in the our civil purposes. So where this concrete can be used. Um, Okay, according to the characteristics, lightweight concrete, Okay, and recycled aggregate concrete. How we can make the construction sustainable. We can use the concrete in sustainable way. So through various through various type of concrete production or cement production, we can achieve this. We can achieve the target. Achieve the target of sustainability. Okay. So, and lastly, in the we have the sustainability. Actually, the sustainability comes in terms of embodied energy. How much energy the particular building material has in in the construction. Okay, regard in terms of its volume, in terms of its usage. So we'll be discussing these things. So these are the few points, and not very much uh, stressful. So still very important to our lives. So option is the first question is the this which of the following is correctly matched means. Okay, first of all, I'm sharing my screen. So I think my screen is shared. So guys, please confirm my screen is my screen is visible to you. Hello guys.
Yeah, it is visible, sir.
Yes, yes. So thank you for for a confirmation. Okay. The first question is the which of the following is the correctly matched? Normal concrete, high plastic viscosity, and yield stress. The same. So actually, the rheology, if you relate it to the rheology, the flowability of the concrete, then this graph tells you the um, tell them or guide you to understand the right behavior or accurate behaviors of the different uh, types of concrete depending on its flowability. So it's actually the rheology. So now here it comes is yield stress. The y-axis is the yield stress. Yield stress. Yield stress. Now this x-axis is viscosity. 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 Now that these are the actually from the observation or experimental observation, this rheology, the values of or the characterization has been done and thus plotted in a yield stress versus viscosity graph. So is normal strength concrete is light here. Normal strength concrete. It's normal strength concrete. Normal strength concrete. Okay. Now here it flowable concrete. Flowing concrete. Now it is high strength concrete. Here this region covers high strength concrete. This tells the position of the high strength. Now this is the yes, this is the pumpable concrete. This the pumpable concrete. Concrete. And lastly, lastly, This is the self-compacting SCC. SCC. So actually, if you check this normal strength concrete, viscosity is low. Actually, viscosity is the viscosity lies in this range. Actually, how you interpret this plot? How can you interpret this plot? So interpretation is like that. This circle or the way it is denoted, you just make a reflection on a or you just subtended this plot or this region over the x-axis. Now then you can find this the range of viscosity where it can be applicable. Now this range of viscosity is low as what I observed for normal strength concrete. The strength of in this viscosity is low. However, it shows higher strength, higher yield stress, or higher yield strength or shear stress. Okay. However, the flowing concrete, it has very low viscosity and also very low yield shear stress. Okay, actually, it's very obvious, right? Whenever the concrete is flowing, so and the flowing whenever the concrete is flowing, the viscosity should be much less. If the viscosity is higher, then layer to layer friction will be much more, and there will be no flow. So for the flowing, for the concrete to show the flowing characteristics, the viscosity should be lower. Okay, and in stress is also low. Um, and then now if I go to the high strength concrete, the high strength concrete is like this. If you draw this axis, draw the axis or central line over it, and you just subtend it, or you just make a cutout over the x-axis, then you will find this applicability in this viscosity range. Okay, or it has this viscosity range. So in this viscosity, this is the high strength concrete is relevant. So and also it has oh, it has this range of yield stress. So this all the plots and all these figures denotes the range of yield stress and range of viscosity, and it is workable. This range of viscosity, it has this range of viscosity. This high strength concrete, there's many grade. There can be many grade based on the mixed design or some higher designing tools, tool or equations. The concrete grade can be varied from and all the category can be considered in the high strength range. Okay. And so that's why these plots are there. These circular plots are there, which determine or give the idea the which viscosity range in this high strength concrete lies, and which yield stress in this high strength concrete lies. Okay, so this figure tells like that. So this actually the viscosity is middle, not less and not much, and yield is also is a reasonable yield stress. It shows some reasonable stress high strength concrete. Actually, this high strength concrete, the based on purpose. So high strength means yield stress in high strength when E modulus of resistance is much higher. So and also this flexural strength is supposed to have the much flexural strength. However, based on the purpose or the working scenario, we can optimize this. We can trade off. We can make a trade off of these two property, and based on our applicability or scenario, we can optimize this yield strength and viscosity property. So and this is how these plots are these plots exist, or these plots are figured out. And this region are figured out. Now pumpable concrete. Now if I come to the pumpable concrete, then its range is lies this way. So its viscosity is much higher. Why its viscosity much higher, and yield stress is not as high as the normal strength concrete. Why the viscosity is higher? Because the pumpable concrete is such a way, such a concrete that it can be pumped out. It can be pumped from the pumping with the use of pumping pressure. It can be lifted to a higher building, higher level of um, higher floor level. If it is not possible by trekking by other means, not possible to take the concrete through other means, it is the best way or the quicker way to pump it from ground level to the top of the floor or the higher floor level. So for that purpose, we use the pumpable concrete, and it should have the viscosity. And viscosity means and in pumpable concrete, actually, there should be no relative movement between the particle to particle, and it has a low yield strength. And because of the pumping pressure, the concrete shows some yield strength, because it has a yield strength, shear strength is yield shear strength, stress is or strength is low, and due to because of pumping pressure, and it's works on pumping by the pumping pressure, it just flows, and due to the pumping pressure, this pressure compressed somewhat the concrete mass, and and with the pumping pressure, this concrete mass are plugged in, and it just flows. Okay, it just move. So yes, there is no relative motions I already described. So that's why the viscosity comes in picture. Now, self-compacting concrete. So self-compacted concrete, it should be plastic. So more the flowable concrete is that. So more is the plastic. So very high. Um, yes, it is actually very high plastic viscosity. It has very high plastic viscosity, and it has a low yield shear strength. So this range tells, okay. So this range tells and this viscosity region. So this is the region. So this is the region. So this is the yeah, this is the viscosity range. This is plastic range, plastic viscosity range, plastic vis viscosity. Viscosity range. Plastic viscosity range, and it has very little, and self-compacted concrete has very little shear strength. Yes. Okay. So don't confuse with the yield strength or yield shear strength with the viscosity. Yes, if the stress is much higher or yield shear strength is much higher, it may or may not increase the viscosity. However, the viscosity is solely related to the how we are using the concrete in our construction purposes. So, and accordingly, we design those concrete. So these are the few insights that is very helpful for you to understand the subject, the concrete behavior. So the first question is the normal concrete is concrete. Then it is saying that normal concrete, plastic viscosity, plastic viscosity. Plastic viscosity, plastic viscosity, and instance. So because it shows this high, first which is high, and it is high also. Uh, High strength concrete, high strength, high strength concrete is low, that is saying high, and self compacted concrete means SCC. It says high and it's low. Okay, so it's like this. Now, from the rheology, you can easily identify which is right or which is true. So normal strength concrete is plastic viscosity is high. They are saying and yield stress is high. So yield stress is high. However, the plastic viscosity is low. So it is not correct. It's not correct. It is not correct. High strength concrete, low plasticity, low plastic viscosity, low plastic viscosity. Yes, it's somewhat correct. And yield stress is high. Yield stress is high. We can't say the yield stress is high because some part, some region also dies in low yield stress. So we can't say like that. We can't convert. So this option also not true. Now the self-concrete concrete is high plastic viscosity. Yes, plastic viscosity is high, is at high range, and yield stress is low, is very low. Yield stress is very little yield strength or yield shear strength. So this is correct. So first question is, third option is correct. So now now which of the statement is true? So the second questions ask the various methodology or various experimental setup through which we can identify or we can check the we can check this compactability, self compactability. So there are various setup. And normal VV SRAM test is not workable at all because it has a specialized concrete. So we have to derive some special equipmental setup so that we can accurately measure its self compactability. To this effect, the researchers has invented the YouTube test, and also the V funnel test, okay, the seep segregation test, and other test also there. So J-ring test, field box test. So these are the few things. There is no high standard actually. And first is the YouTube test. So L box test also. Okay, I told the L box test. Yes, segregation resistance is L box test. I'll be showing the test one by one. Wow, how does it how does it work? So the first of all, this to first I have to let me list down this the various tests through which we can identify or we can measure or quantify the self compactability, the compactability of the concrete, so that we can call it the self compactive concrete. So first of all, this one, the various test. Oh, fast test to identify, to quantify the cell compactivity, or to quantify the compactivity. Okay, the first test is the popular test is the YouTube test. YouTube test. So first is YouTube test. So this test is effective only in judging whether or not this concrete has sufficient self compactability. So this said only judge whether cement has, or the concrete has, the concrete has sufficient self compactability. Okay, so if the concrete doesn't have the have sufficient self compatibility, the the cause can be detected, and accordingly the mix designer can be changed. The procedure of mix design can be changed and adjusted, and several trials can be arranged to make it a self compacting in nature. um, okay, so what are the test mechanisms? They say U tunnel is there. U-shaped tunnel is there. So this is U-shaped. So U-shaped tunnel is there. So I am drawing three pictures. Three pictures I'm drawing. Fast. So this. Yes. So this test is say this is the this two steep concrete, two steep and viscosity is very high. Steep concrete and is too flowable. Flowable. Viscosity is very low. And what we did, this is only we have a gate here. So this is the this U-tube is segmented in two parts. So the below the barrier in bottom of the barrier, one gate is there. So one gate is there. Okay. So one gate is there. Bottom of the barrier, one gate is there. So this is called this. We can lift the gate, and what we did, what we do actually is we fill the concrete. First we close the gate and we fill the concrete. Okay, so this is my concrete, and we are checking its compactability. And gate we and we fill the concrete this side, left hand side. Now we lift the gate. So now I have to give some insight about the for the gate characteristics. So how the in what way this or the gate has designed or designing some geometry. So some geometry I'll try to show you and how this gate has been is designed. So this gate has actually this is the gate made of the rebar. So actually this gate is made of the rebar. So I am showing some cross-sectional view. So this is the view, and this is the side view, right? This is the side view, and this can be the front view. So this is the gate, and in the gate this is the rebar position. This is the rebar position. Okay. So actually these are the rebar dia, and this rebar dia is 16.5. So and this gate has a certain at certain interval these rebars are placed. So in this is the configuration of the gate. And now now we are lifting the gate. Now we lifting the gate. So this is my gate, and we are lifting the gate and let the concrete flow from this part, this section to this section, from section 1 to section 2. So it will flow like this, and it will fill the space. It will fill the space. So let's say it fill the space like this much. So it is not good. Not good. Not good means not good. So and now in the second, we did the same way. We did the same way. Okay. And now concrete move to the second segment, and it feels almost at close to the previous level, close to the field, almost to the close to the previous level. Actually, this the ideal idea of the self-compacting, good self-compacting nature is that when we leave the gate and make the let the concrete flow to other segment, so it should at least it should touch or actually satisfy, or the two levels should come at a equal. In segment one and segment two, the concrete level should be at equal level. Should be at equal level. That is the ideal case of the self compactability. If it is slightly less, then it is also okay. We are happy with it. So the ideal situation is that it should be at the same level. However, with that, if it is like this, so we can say this is good. Is okay. Okay. Now, if I mm, now if I remove this gate and let the concrete flow to this side, now it moves this much, this much, and it is not okay, not okay. So this tells not okay. Okay. So actually, this we have to you have to be very cautious, and this is the and this is if it also if if it was also rise, so we have to be very cautious about this movement. We have to check whether this any segregation taking place, or segregation means this, and the solid particles remain this side, or the concrete is coming with the solid particles, or the solid particles with the from segment one to segment two. We have to be very careful of this. So if the concrete, the solid particle remains here, and it is moving on, only the water is coming, only the fluid or the paste is coming to this side, it is not desirable. So you have to check this thing, when whether this paste along with the solid particle, along with this coarse particle, are moving from are, uh, equally equally moving, or simultaneously moving from segment one to segment two. Okay, so solid should not stuck here, so that if it is stuck there and it is reaching this level like before at a level in one, so it is not desirable. So you should look into this aspect very carefully. So solid should not stuck here, and the fluid yes. So if it is there, then we have to redesign this mix design process, re-establish or calculate the mix design calculation. Okay, so so this is the case. So when we consider this first, second, third, so we when we consider this. Sorry, so we consider when we consider this uh, so when we consider this second one, so it is the right choice. So now this we can we can also measure the fluidity or deformability. Is show the sum flow or funnel test. It's very popular. Slum flow and funnel test measures the fluidity, measures the fluidity or deformability. Deformability. Yes, deformability. So fluidity is determine the slump. Actually, this fluidity. So the sum flow determines the fluidity. Criteria to satisfy the criteria that self-compacting concrete is satisfied by the sum flow state should be 64 to 65, 64 to 75 flow. Or okay. Actually, Actually, this IS 456, IS 456 2000 specifies tells that the 600 mm in so actually it shows this flow with time. So flow means 600 mm. It flow the 600 mm to distance of 600 mm per minute. So if it is there, then you say that it satisfies the criteria cell compact concrete. Actually, in the thumb flow for good cell compactability, the slump flow test should show 64 to 75 centimeter. Okay, so if it is less than 64, then it is highly viscous. If less than 64 centimeter, then it is the highly viscous concrete. And if if less than
Sir,
it is called.
this is centimeter or millimeter? 64 to 75 centimeter or 64
Yes,
to 75?
600 millimeter. So actually, IS 456 said that 60 centimeter, and 60 centimeter IS code said I 60 centimeters. So millimeter you can easily convert to this centimeter, right? So it's not a big issue. So normally it is said that 640 to 750 millimeter. So I just said in terms of centimeter, and IS code said it is 60 centimeter per minute. So this is so it is called shows the highly viscous concrete. Highly viscous concrete. Now, V tunnel test. V, V funnel test. So it directly gives the measure of the viscosity. It directly gives the viscosity measure. Viscosity. Okay. So actually, what the test is like that. This is a this V funnel is there. So V shape funnel is there actually. V shape funnel is there. It has a bottom opening, and you put the concrete over here, and actually it is like a 3D. If you make it a 3D view, so this is how it's look like. So this is the V funnel, and if you the concrete over here and you just open it, so you just open it. This is the bottom opening. This is the bottom opening. You just if you open it, then it will come down. The concrete will come down, and you just note down the time. How much time it takes to empty this funnel or this V-shaped funnel. So this measure she gives them direct measure to the viscosity, and it says that for SCC for SCC for self-compacted concrete, the time duration of full discharge, the time duration of full discharge is 10 plus minus 3 seconds. So yes, now if some concrete, if the concrete takes less than this threshold value or this limiting value, then this show some segregation issues. The concrete has some segregation issues. Means these fluids are coming fast. Fluids are coming. There is more fluid, and the solid material are stuck behind. It is not coming down. Whether the space are removing, getting out of the funnel. So the segregation issues are also there. So if too high, it means the viscosity is very high. Means high means it is above this duration is above the duration, then it can be concluded this viscosity is very high because it's very viscous material. That's why it takes more time to discharge all the concrete that fill in the V tunnel to discharge it full to empty the V funnel. So that's how it's measures this V funnel. Uh, that's how this V funnel works. So now is segregation resistance. The segregation resistance is the segregation resistance. This segregation resistance is directly measured by L box test. L box test. Okay. So actually, what is the L box test? So this test is like this. This is this is the L box. So actually, I am showing this side view. Side view. Actually, this is like this. If you make it a for your own understanding, I am trying to show this 3D view. Okay. So this is the funnel. Now it has some bottom opening. Now this bottom opening. Now this part is open. So this part is closed. This part is closed. You pour the concrete over it, and this part is closed. And this is the okay. So this is how does it look like. So you pour the concrete, and when the concrete is poured, actually here it is you have one gate. The gate is there. The gate. So you pour the concrete, and after make it a full or a certain level, you just lift the gate. And how this concrete that is in that vertical chamber now flow to this horizontal chamber, how much it gets subsided at the end of it. So these are the measures I am telling you this right now. So how you measure the segregation resistance? So vertical part of the steel box is filled with the concrete, which is left to the which is lift which is lifted for 1 minute. This get be lifted for 1 minute, and during this time the concrete will display whether it is stable or whether there is some segregation. So this is a test criteria. You are lifting this gate for 1 minute, and you are observing how much and this how much the how the stability you are checking or observing the stability of the concrete. Okay. And if there is some segregation is taking place, so how you can measure it? So this is we are doing the side view option. So this is the side view, and you are filling this quantity of you suppose you have the h. Okay. Height. Okay. Now you have one gate here. You have one gate here, and the concrete you lifting the gate for 1 minute, and you let the concrete flow from vertical chamber to the horizontal one. Okay, so it flows like this way. It's flow like this way, and it's end up with this height, h2. So if it is suppose it's h1 and it's h2, then if h1 and h2 by h1 is 1, then it's perfectly stable. Is then it is perfectly stable, perfectly then it is perfectly stable and it can be said and can be said and efficient or can be said as a perfect or ideal as ideal HCC cell concrete concrete. Okay, so these are our target. So now the height of the field and the height of the concrete is to our measure. So these are after making after let this gate open for 1 minute, how much this height and how much this h1 height you can measure easily, and you and make a ratio of it, and you can get the idea how much it has the compactability or it has the segregation. And so actually this measures the segregation resistance. However, the criteria to satisfy this SCC is at least that H2 by H1 should be at least should be at least 0.8. Okay, so this is the segregation resistance. Actually, this tells the this actually this identify the segregation resistance property of a self-compacting concrete. So with this identification, we can say this particular concrete is self-compacting in nature. So now the SIP segregation test. So actually this also some test also there. This is not important shift segregation test. So in the in the test show this allow the concrete to stand in a bucket for 15 minutes. Pour top 2 liters on the sieve of 4.79 mm with the pan below, and ratio of mass passing to the poured mass is measured as segregation resistance. Actually, this is the sieve. This is the sieve. Okay, so this is the sieve, and so allow the concrete to stand in a bucket. Actually, this is a bucket, and you make it stand for 15 minutes. Pour the top 2 liters on the sieve. After making after 15 minutes of stand in the particular bucket, this is sieve is there, and you top 2 liter of 2 liter of the concrete specimen on the top of the sieve. Actually, this sieve size is 4.75 mm. Okay, this sieve size with the pan below. So pan below. Okay, this is the pan. Sorry, this is pan. And ratio of the mass poured. This is 2 liter. 2 liter. And ratio of the mass poured. How much you are pouring? You have poured the. You just convert the liter to the mass in kg with the density. By multiplying with the density. Okay, or the volume. Okay, yes, with the volume you can just get the idea of how much mass you have put in poured it, and uh, how much it is passing. So passing divided by pour gives you the segregation resistance through sieve analysis. Gives the segregation resistance through sieve segregation analysis. Sieve segregation test. Okay, so actually 5 to 15% is satisfactory. If it is less than 5%, then has high resistance, shows the high resistance resistance. If more than 15%, then it's possibility of segregation. The concrete has the possibility of segregations. Segregation. Okay. So actually the possibility of segregation means the fine content is much more. Fine content is more. Content is more. That's why the paste content is much more. Okay, compared to the equal segregated content. So in that case, the segregation is a possible phenomenon, possible occurring. Can possibly occur. The other test also say T50 test. So these are not a good popular, but still the test exist. exist, and the T50 tests are there. Time for this tells us time for uh, 50 centimeter slump flow. Okay, so it's again shows this slump flow, slump flow against the time. So also this a J-ring test, J-ring test, test is there. Okay, so actually this slump cone is there, and these are the tray. So these are the tray. So actually this tray is like this. So this is the slump cone. This is the slump cone, and this is the tray. This is a circular ring, and the ring actually, this ring has some obstacles. This is some river. So river obstacles is there, and you just move the just remove or lift. And this you put the concrete here, and you just lift the slump cone, and you just check, you just observe the fluidity and the passing ability. Okay, you just observe the fluidity and passing ability when the concrete strike, or when the concrete strike to the obstructions. These are the obstruction. How does concrete behave? What are the effects on flowability and the passing ability? Okay, fluidity and passing ability when it stuck with the strike, when it strike this its obstructions. So this is J-ring test. Now and also other tests also there's no IA standard. There's no IA standard. IA standard. No IS, no IS standard, Indian standard, no Indian standard on finding the compatibility. However, there is also European code also there. So European code also the is EFNARC 2005 is European, and JSCE is Japanese 1998. Actually, this Japanese standard for civil engineering. Japanese Japanese standard for civil engineering. So these are the tests. Now we can come to the question. You can easily find out the right answer. There is no need to say. Yes, the first statement is the L box test is a measure of the viscosity. Is it the L box test? L box test means already showing. This is the L box test. So this L box test directly it is, yes. So it measured the segregation resistance. Is measured directly measure the segregation resistance. So L box directly measure the segregation resistance, and it says the first statement says that L box is a measure of viscosity. No, V funnel test is a measure give the is saying that is a measure of segregation. No, it is not the measure of segregation. It directly measures the viscosity. Okay. The last option is the slump flow is a measure of fluidity. Yes, the slump flow is a measure of fluidity. The final slump flow and the final test the measure of fluidity and deformability. Fluidity or deformability. Okay. In its plastic state, when the concrete is in plastic state. So the third option is the correct. The third option is the correct. So the second option says this third statement 3 is correct. Now third question. The what of the following statements? What are the of the following statements is true regarding the fiber reinforced concrete. Okay, so fiber reinforced concrete, I am telling you the concept here. Actually, this is fiber reinforced concrete, right? Fiber reinforced. C part C. Okay. So yes, just now I have to take your attendance. The fiber reinforced concrete. Actually, what happens fiber reinforced? And the fiber reinforced means you are introducing the fibers inside the concrete. Okay, concrete matrix, concrete system. So this is your concrete section. Some of this thing, concrete section, and this is the concrete. This is the aggregate, and this is the base here. And you are adding some chopped fiber. So these are the chopped fibers. Here I say this is the fibers. No, no, this. You see, these are the chopped fibers. You are in random orientation. It's random orientation. Orientation. Okay, so they were, and this is one type. It's randomly oriented. This is randomly oriented fibers. Randomly oriented fibers. Now this is oriented fibers. Randomly oriented, and it is this aligned fiber. Okay. Now this concrete section. See, same concrete section. Now these are the aligned fibers. These are the aligned fibers. Okay. So concrete section. So this is aligned. Aligned fibers. Aligned. Aligned. So so actually the concept of introduction of this fiber inside the concrete is the resistance against the crack propagation. Whenever the crack is propagated, see this is the crack. See, the crack is somewhere here. So crack is somewhere here. So whenever this crack is there, and it will just try to split the concrete from that cracked of this portion of the crack. When the crack where the crack is generated is try to split the concrete from that portion. Then split means it will be having it will be imposing some tensile strength of the concrete. Okay, and if the fiber is there, then it can easily take this tensile strength. Okay, so with this concept, this fiber reinforced concrete has been introduced in the engineering in engineering constructions or building constructions fiber. Okay, and for the aligned fiber also same thing is there. So there's also theory that tells this strength, fiber input concrete strength in terms of matrix and fiber. If and obviously we are giving the strength. We are maintaining the strength of fiber higher than the matrix. If the matrix is lower strength, then the matrix would fail. Uh, Fail. But however, this fiber will not fail. If the fiber will not fail, it will make the concrete intact under the loading. Okay, so these are the few important things that tells this workability or this it enhance the concrete performance against the loading. Okay, so there are many theories, and also we'll be seeing some equations of this. If the L if there's some critical length is there. Okay, so we'll be telling some, we'll be discussing this part actually. If the critical length of the fiber, okay, if it is if the cracks are less than the critical length, if the cracks are more than critical length, how the stress block will be getting varied, and what are the factors, correction factors are coming in picture when we use the randomly oriented concrete. For the aligned concrete, there will be no such correction factors. So we'll be doing that. Not a detail, but a overview. I'll be giving you some overview. Okay, the first the this property, this FRC property is the improves crack resistance resisting property, crack arresting property. It improves the crack resisting property. The first property is the crack arresting improves the crack arresting property. Crack arresting property. Second is pseudoductility, shows pseudoductility. Pseudoductility. Ductility. Actually, the pseudoductility means it shows some nature of the ductility and some of the brittleness at the same time. Okay, so it is called the not the purely ductile, not purely brittle. So it is a pseudoductile. Um, uh, Now it is showing flexural strength, improved flexural strength. Show flexural improved shows improvement, improved flexural strength, flexural strength. Or low workability. It has a low workability. Actually, whenever the fibers are there, there is some friction with the fiber and the matrix. There is some friction in interface. So due to the friction, the viscosity will be much higher. And as the viscosity becomes higher, then it is low workable. It is low workable. Low workable, and this depends on this L by D ratio. Okay. Yes, L by D ratio, that length of the fiber by dia of the fiber. Okay, and D by ratio depends on the D by ratio, and also low workability also gives a better bleed resistance. Also gives and this better bleed resistance. Bleed resistance. Okay, and the high cement content has the high cement content. High cement content low, you may say low um, mean standard aggregate. Okay, so these are the few points that characterize the FRC. So the first statement tells the improved characteristic properties. Second tells the decrease the ductility. We can't say that it decrease the ductility because it shows the ductility. It shows the ductility, but not that pure ductility, but some brittleness also there. So improve. Now third statement is improve the flexural strength. So option one and the statement 1 and 3 is correct. Statement one, the third question. Statement 1 and 3 is correct. Are correct. Now this latex modified type of, yes. Now we can go to we can come to the polymer concrete composites. Okay, so actually this polymer concrete composites, if we say um, special concrete comes on the special concrete. So actually, these three types of composites, the polymer concrete composites. Actually, in polymer concrete composites, we are replacing some part of the cement or cementous material, or is actually the powder. Cement is said as powder. So we are replacing some powder with the sorry, with the polymers. Okay, polymeric materials. This is called the PCC. This PCC. One part is PCC. Second is PC, means polymer concrete. So here the cement or cementous material totally replaced by with the polymer. Okay, and polymer impregnated concrete. Polymer impregnated concrete. Polymer impregnated concrete. So polymer impregnated concrete means we are introducing the polymer with the pressure. With the pressure we are introducing, or we are we let the polymeric particles. These are small particles of 5 micron. We are pushing the polymeric material, polymeric polymeric particles inside the concrete already uh, already hardened concrete. You can say the hardened concrete. You are pushing this pushing with the pressure, hydraulic pressure. You are pushing the particular polymeric material inside the concrete so that it has a good. It can improve the its behavior against the loading. So this is the idea. And now it says that the hydraulic cement binder with the hydraulic cement binder is the this cement. Actually this cement is nothing, this cement is a binding material. If the gel formation is there with the reaction with the water, when the gel formation is there, it shows some binding properties. So that's why the cement is the binder, can be replaced partly by the polymers to form polymer modified mortar or concrete for repair purpose. Actually, this polymer concrete composites is very costly because it's when you make it for a large purpose or large construction purpose, then what you are doing, you are replacing the cement. Actually, the cement is cheaply available and it is comparatively cheap as compared to the polymer. Okay, so that's why it mostly used for repair purpose. Okay, so it is called the latex modified concrete. So elastomers are the polymers which are the elastic in nature, exhibits elastic recovery under low strain. So under low strain is like rubber materials. So under low strain it will revert the. So if we actually use it in the repair purpose, then it shows this better applicability. So and now you can also you know very well this how the polymer makes is the repetition of monomers. So now the latex is an ultra fine emulsion. Latex is an ultra fine emulsion. After coagulation, the material behaves like a rubber. So latex is an ultra fine emulsion. Emulsion means these small particles. And after coagulation, emulsion is this not but this fluid type of material. And after coagulation, it shows them solidified in nature and it shows some grain inside it. So the grain is like a one to one size of the grain is ranges from 1 to 5 micron, is spherical in nature and small particle shape, small particle. Okay, and it acts like a filler. It solidifies and reduces the porosity. When it reduces the porosity, it increases the strength, and so that's why it shows the strength enhancement. So yes. So actually, this polymer impregnated polymeric concrete by the ordinary concrete. If it is say that strength or moment of resistance, or you can check the strength for the polymeric concrete, it is 1.5, means 1.5 times more than the ordinary concrete. So yes, because it is a costly material, so you can't use it in large scale. But however, we can use it as a repairing type works. So so it is called the, so that's how it is latex. So the fourth option is the latex modified concrete is a type of polymeric composites, and later behave like a rubber after coagulation. Okay. So this it's true actually. The whenever you are adding some polymer inside the composite, so so it is called the latex modified, because the latex is the emulsion after coagulation. It behaves like a rubber or elastomers. So it's the statement is correct. So the this fourth option is correct. True. Now the fifth question. Fifth question says this: which of the following benefits does this lightweight concrete has? So lightweight concrete, mostly the concrete which is where this the lightweight is the main purpose. The weight is the main purpose, design purpose. We reduce this weight by introducing there's airs or voids inside it, so that the porosity becomes much more. Um, and we can also use some lightweight aggregate. And okay, so and there's also some methodology through which we can make we can prepare we can or manufacture the lighted concrete. Okay, so is aerated concrete is the one method. Autoclaved blocks. This is another type of lightweight concrete, and foam concrete, where actually aluminum powder foam or organic agents are introduced, which can generate a foam inside the concrete. Foam means which void, just the concrete. And fly ash also takes also claims this lightweight property. If you use the fly ash inside the concrete, it also gains the lightweight property of the concrete. Okay. So actually, this lightweight concrete is mainly particularly used for the thermal insulation, and sometimes it can be used for the acoustic insulations. And seldom or it is not important. Is sound insulation. In purpose of sound insulation, we can also use this concrete. However, for the sound insulation, the concrete blocks, rather than this materialistic property, the material property, if we change the geometry of the particular concrete block, then it has a much effect on the sound effect. So if it is make it, say if you can also see the brick masonry. So the brick masonry with the hollow side section, with the hollow section, shows the better sound insulation as compared to the solid. And so we have to make a some gap whenever the sound wave is tracking. So it should not pass through the section, throughout this concrete masonry section. So if there's some gap, then then only you can obstruct this sound obstruct the prevent the sound wave to propagate further. So rather than this material property point of view, if you changes is some if you introduce or if you make some changes in design or in design or architectural design, or if you change the shape of a particular concrete block, then it will be a the best option for improving the in order to improve this sound insulation property. So actually the lighted aggregate is not popular in India, um, not popular in India, and this fly ash, um, which can be used for to construct the lightweight concrete, can be made from sintering process. Okay, so now there's some plot which shows the thermal conductivity with the change in porosity. So these are the plots. These are the plots. So this axis shows the thermal conductivity. This is the thermal conductivity. This shows the porosity. This is the thermal conductivity porosity. Okay. So this is the trend. So this is dry stage is saturated. When the concrete is saturated, so this is like this. So you check in both of the scenario, dry and saturated scenario. If you increase the porosity, if you increase porosity means voids, then drastically reduce the thermal conductivity, drastically get reduced. Okay, so it is the important parameter with which we can control this thermal conductivity. So with this lightweight concrete claims the most claims the highest thermal insulating property or can be suitable, can be most suitable for insulating the thermal energy, prevent the thermal energy to pass through. Okay, so the lighted concrete. So lighted concrete is used for the thermal insulation purpose. Okay. Yes. So the sixth question. The sixth question tells this thermal insulation. With thermal insulation. Insulation. Okay. Now, yes, and there's a fifth. Sorry, this is. I think I mistaken. This is. I think, and the previous was sixth question. Previous was sixth question. Now is. No, I think this is sixth question. I just made a mistake. So this is the fifth question. Now we will discuss the fifth question. The fifth question says this latex type PCC is polymer polymer cement concrete. It can be used for the repair work. Is already we have seen this can be used in repair work. Impregnated polymer can be used in bridge deck. Actually, there is some impregnated polymers means this we are introducing. We are introducing the this fiber or this polymeric particles inside the concrete with the pressure. So the pressure can be applied on top of it. So this is the section of the concrete. So this is the section of the concrete, and we are placing a some hydraulic equipment over it. Hydraulic equipment over it, and we bring a pressure. Okay. So what happened? See. These are the aggregates. These are the aggregates. These are the aggregates and the paste. Now, now these are the voids. These are the voids, chill voids. Now, if we are introducing this polymer, if we are impregnating the polymer from by with the pressure, then what happened? It will just pass through the barrier and it will fill the porosity, this void spaces. So what happened? Just fill the void spaces. So this way how does it work? So hydraulic cement binder is impregnated with the low viscosity monomer that is polymerized to form the uh, to form this polymer impregnated concrete. So hydraulic cement binder is impregnated with the low viscosity monomers. And this polymer or monomer is the small is micro scale. Polymer is a macro scale, monomer is a micro scale. If the mono the chain of monomers form the polymers. So it is a micro level particles. If we can impregnate it with the pressure on top of it, and we can form this PIC. PIC. Now concrete surface becomes impervious, stronger whenever we are filling this void spaces with this with the polymeric particles, the monomers. Then what happened? It become dense, it become dense, and it will become less impervious and stronger and durable and high abrasion resistance. It has a high abrasion because whenever you are abrasing, you are in some continuous movement of vehicles over it, particular deck or something. It has a high resistance. Okay. Um, so and successfully used in beach deck wiring code. Actually, in the beach deck, this is the beach deck is there, and this is the wheel load is also there, and continuously they are moving here and there in this direction. So this abrasion is the very relevant scenario in the beach deck. And if we introduce this PIC, this polymeric concrete, then it has a high abrasion property, resistance property, and it will be a good choice. Polymerization, yes. Now I can say this this how we are introducing this polymeric material inside the concrete. Actually, there is many way you can do is by thermal in elevated temperature condition, in radiation technique, through radiation technique, or through thermal arrangement or elevated temperature arrangement radiation technique, we can introduce the monomers inside the concrete. So that's how we are impregnating the monomers inside the concrete matrix. Okay. So this is the heavy concrete. Now the heavy concrete is actually the heavy concrete nuclear reactor. Actually, this we can use this concrete in the nuclear reactor. Whenever this cooling tower is there, and there's a problem, some radiation systems are involved, we can use this heavy concrete. What happened? This is this concrete block is there. Concrete block is there, and some it is exposed to some radiation field. What happened after this is the radiation? This is gamma radiation, the gamma or X-ray. X-ray photon, X-ray radiation is there, photon energy is there, and when it passes through, it shows this. Okay. So this is the attenuation. This is the attenuation. Okay, so actually the major problem in nuclear industry is to attenuate the gamma ray or X-ray or neutron energy emerging from the core by means of the biological sheet or some heavy structural components. To overcome the cheapest way to overcome this problem is to apply the heavy concrete. Okay, so it will act as a shielding material. So actually shielding material with the hematite and barite, which has a specific gravity of 4 to 5, uh, will will satisfy these design criteria of the heavyweight concrete. Okay, so actually this. we can also actually the designer use equation for the radiation field. Actually, when you are designing some concrete exposed to some radiation, there should be some loading curve. So loading curve is expressed with this. So I radiation is incoming radiation. Sorry, this is radiation at any instant of time or any at a particular certain distance. So this is the x, this x is there. So this is the incident radiation. This is the incident radiation I naught e to the power minus mu x. The mu is the mu depend on the density. Okay, so density means this X-ray intensity. So this density depends on other factor, but the mu is mainly is a function of the density. So this is all about the heavy concrete. So this fifth question is which of the following is correctly matched. So latex type PCC is for repair purpose. Is it get whenever it formed, it will be after coagulation. The rubber will form this emulsion type material form and will just fill the space. It will just fill the space whenever the cracks. If you apply this particular PCC, it will fill the cracks and make the void fill, so that there will be no further action of rubbing or something. So it will also give a good resistance. Not a rubbing, it will also have impervious nature property. It will impart impervious property to the particular cracked section. Okay, so this way we can use the latex PCC. The impregnated polymer with impregnated polymer, the breached the abrasion property get improved. That's why you can use in bridge decks which is frequently subjected to repeated wheel loads. And the third option is the heavy concrete, and which can be easily used in the purpose of shielding radiation. Okay, so as a protective structure, we can use the heavyweight concrete. Okay, so all the options are true. Now the geopolymer concrete. Actually, in geopolymer concrete, what happened? We use the high fly ash content. Okay, and okay, so we use the high fly ash content, and where we are replacing totally the cement content. Okay, so that this cement actually this all concrete are evolved because of this embodied energy. Embodied energy is associated with the sustainability. So what is the sustainability? How sustainability is that we are using some part, we are using material, and we are extracting, we are exploiting the resources for nature, and we are not thinking that our future generation will use it or not. We're not thinking about it. This is the unsustainable, mostly unsustainable, because and then this sustainability comes in terms of this energy. Okay, so this is embedded energy. Whenever we are doing some masonry works or some plastering works, is always takes some energy. Okay, so embodied energy. So the particular construction material which has the highest embodied energy. Uh, and if we use it repeatedly, then we are particularly using that energy. We are using the higher energy. We are exploiting the higher energy. We are not thinking about the sustainable. We are not thinking in sustainability point of view. So that's why we are reducing the application of the cementous material, or cement, particularly cement, not cementous material, particularly cement in the concrete system. That's why we are introducing some geopolymeric material inside the concrete, so that it can behave as as good as the cement does. So actually, this geopolymer cement concrete is utilizes the polycondensation of the silica and alumina and high yes, for polycondensation of silica and alumina, and it has a high alkali content for strength. Whenever the alkali content is, it has a high alkali content, and for the stain purpose, this alkali content are optimized, and curing temperature is 60 degree or above or below, so approximately 60 degree. So there are some mixture rules that I'll discuss uh, after we finishing these questions. Finish these questions. So, which of the following material used for the construction have the highest embodied energy? So, actually, it is concrete that I just recently, I am just telling you recently that the concrete has the highest embodied energy. If we are using the concrete, or concrete is concrete repeatedly in our construction purpose, and then we are utilizing highest utilizing the particular construction component which has the highest embodied energy, so and it adversely affect our sustainability. So okay, so if you check the embodied energy, the masonry has this least embodied energy. The masonry masonry embodied energy is the on 100 gigajoule. Plastics embodied energy is the 150, 145, 145 gigajoules. Concrete embodied energy of 225 gigajoules. Steel embodied energy of 135 gigajoules. Okay, so actually this concrete, why the concrete does have the highest embodied energy? Because of this largest volume. Whenever we are using concrete, always this concrete quantity, if you check, if you just observe the concrete, uh, the amount of concrete we are using for a particular construction is maximum other than other materials. Okay, so because of this sheer volume, sheer volume, and the important energy is maximum. Yes. So um, that's why to taking consideration of the sustainability, we can use the fly ash concrete, geopolymer, fly ash cement, fly ash in place of cement, so that it can be the embodied energy can be reduced to significantly. You can reduce the embodied energy significantly so that we can maintain sustainability. You can use geopolymer. These are the newly devised material, that is supplementary material. We can just replace the cementous material with this geopolymers, and he said that it is observed that it is showing as good. It shows good uh, uh, good behavior, or it shows better performance, or comparable performance as what this cement does. Now for the embodied energy, I want to specify this energy used in production and transportation of the material called the embodied energy. What is the embodied energy? So it is the production purpose and transportation. So these are all included in the embodied energy. If the production purpose, how much energy you are expending, and the expenditure of our energy in making the particular production, and the transportation, how much energy is getting released due to getting released to the nature due to the transporting the particular item. Okay, so these are all included in the embodied energy. Okay, so manufacturing of the epoxy is only next to the fossil fuel burning. If you check that ordinary Portland cement manufacturing facility, so lots of energy are getting freed or they are just liberating lots of energy to the nature. So, and it's actually is equivalent to fossil fuel, burning of fossil fuel, and and thus contributing to the anthropogenic greenhouse gas CO2 gas emission. Okay, 5 to 10%. So India is the second largest producer of the OPC. So there should be some comprehensive study on that, and the regulation should be imposed so that OPC can be replaced with some other cement, where this in this particular energy consumption in terms of production and transportation get reduced significantly, so that our society becomes sustainable. Okay. Now we can also use the recycled aggregate into the context. I also want to focus on the recycled concrete aggregate concrete, where we can just demolish a particular construction, and we are taking out some debris. We're collecting the aggregate from the debris, and you can repeatedly using that aggregate to the new construction purpose. However, one issues is very relevant to this. Whenever we are using that and is already casted, and the aggregate has original interface with the motor. So if you see, there's some motor already get attached with the aggregate, and the original interface is already exist, and we are not removing particular attached motor. And what we are doing, we are using that same motor attached that original interface with we are and that particular aggregate with our new introducing this particular recycled aggregate to our new mixed design, or a new paste, to making a further new paste. Then what happened? Then another layer will form over the particular interface, the original interface. The secondary layer will form. So that's why the bond will be not that strong. Okay, so this have to be taken into consideration while we are using recycled aggregate. And we can use as a recycled aggregate, we can use the pond ash, bottom ash as a fine aggregate. So this pond ash bottom is largely available in our in industry. Okay.
Sir, repeat the fourth question.
Yes, tell me. Yes, Aditya. Are you telling something?
Yes, sir. Repeat the fourth question. Latex modified concrete is a type of polymer concrete.
Your voice is not coming clear. Can you again can you repeat your question?
Sir, repeat the fourth question.
Oh, fourth question. Fourth question is, a latex modified concrete is a type of polymeric concrete composite, and later behaves like a rubber after coagulation. Yes, actually it is true. Whenever you are using the latex modified concrete, is actually we can use it as a repair purpose. We can use it as a repairing purpose. So it will. So actually, latex is a ultra fine emulsion, and after coagulation, the material behaves like a rubber, or this is elastomers. And it's about 1 to 5 micron in size, is spherical in shape. So it can be used in the repair purpose. So actually, doing this latex modified concrete is very costly if you use it industry purpose. Okay, industrial construction purpose. So and we mostly use it in repairing works. So that's why it says this it will be after coagulation, it will behaves like a rubber. So it is true. The fourth question is true. Only says now this fourth question is true or false. So fourth question is true.
Okay, and sixth one, Is thermal insulation or
Yes,
sound
thermal
insulation
insulation.
both of the above?
Yes, thermal insulation is obviously is the prime. It has the more particularly the lighted concrete is in thermal insulation, because when the thermal insulation depends on the porosity. Okay, so and I have also shown you the plots how the thermal conductivity get reduced significantly with increasing porosity. So you can check the plots. I already show that it is already included in video. In that you can check. I have shown you the graph plot. I have shown you the plot. I'm again showing the plot to you now. So, this is the thermal conductivity. So thermal conductivity get reduced significantly with the increase in porosity. In saturated condition, dry condition, the two plots are there. So it is very obvious that in the lighted concrete, we are introducing the porosity by by introducing some or air inside it, or in the autoclave test. Okay, by using the foam concrete, we are using this radiated concrete. We are introducing some voids inside the concrete, so that the voids become much more, so it become much lightweight. So in that so doing the purpose of doing that, so making it a thermal insulation, the main purpose. However, it also shows uh, some sound insulation, acoustic insulation. Also, there's some properties, but the main purpose is the thermal insulation. Okay,
So the correct is only thermal or both of the above?
thermal is both of these. See this the both. You can say both of the, but if it is particular, if it is particularly this lighted concrete is for thermal insulation. Okay, so it can also provide the sound insulation, but is not that significant. So I can tell you that this much. Okay, so if both are there, then you can opt this option. It's your choice, and this is the true actually. See, all the property, it shows the function, both the function, thermal insulation, sound insulation, but particularly the thermal insulation. If it is more properly to say, it has the thermal insulation property as compared to sound insulation. Okay, if you compare the two. So this is the question. So, and how you can answer is about to you, that what should be actually. To me, if this both of the both these options is available in the question,
Yes,
so I
I
think
want
it is both.
yes, I want to tell this because there is given both of the above option.
Mhm. So you can opt a both option, because it's also provides some sound insulation. It also provides some sound insulation. So both of the option is correct. Yes, particularly the thermal insulation, but both it can also provide sound insulation. So both of the uh, answers are correct. Okay.
And the last one, first one is
First one is right. The first one is the third option. Third option is correctly matched. Actually, cell compact concrete is. I have already shown you these plots, right? So I think in this plot. Yes, this plot actually. If you check this self-compacting concrete, it has the highest viscosity range, plastic viscosity range. However, this has the least yield shear strength, yield strength. Okay, so self-compacting concrete means it should have that viscosity with the cohesion among the particle to particles. Okay, uh, if it is yield shear strength is much higher, yield shear stress is much higher, then it can move, it can flow. So in that sense, you can understand how the commercial compacting concrete behave. So the last option is correct. The second and first option says that normal concrete. If you check the normal concrete diagram, the normal concrete region lies at the top of it, and which tells that it has the higher yield strength, but lower viscosity property. However, this high strength concrete has a medium range of viscosity. However, it has also some low yield stress. So The yield stress may not be the high. So based on the purpose, how we are manufacturing the high strength concrete, we are defining this yield strength property. So, and particularly this SCC, that it self-compounding concrete, this option is correctly matched. So that's why this third option is correct.
Okay.
Aditya, anything more you want?
No, sir. Thank you.
Okay. So I'll be discussing few points. I think it's almost 5:53, 7:53.
Yeah.
So are you joining tomorrow? It is 6:30 to 8:30 p.m. The extra session will be there. So
Okay, I will be there.
okay. So we'll be discussing in this multiple choice question rigorously. It will be good for you, and in the period I am not able to manage those times. So, however, I try to complete some part. So will be a thorough discussion on the questions. It will be good for you.
Okay.
Theory, actually, I'm looking some theory. Most of the part I have covered. I left some particular theory actually. Yes, actually, the basic theory of this short fiber and long fiber. This is also if you go through some literature for a composite structure, this composite actually the concrete is the composite. The composite is composite. There is two parts of the concrete. Is composite. It is matrix and the fiber option. So matrix is the it can be the epoxy, and the fiber can be a carbon fiber, glass fiber, so etc. And the same thing is also relevant for this fiber reinforced concrete. But the concrete system means the concrete with aggregate, mortar, this fine aggregate, coarse aggregate, and paste. This is the concrete. This is the matrix. And when we are introducing some fiber inside it, so it is a fiber. And this material for to improve the tensile strength of the uh, concrete. Actually, the flexural tensile strength, not the direct tensile strength. It is the fiber, and rest is the matrix. So actually, there are two basic theories where we are introducing some randomly oriented fibers. We are arranging randomly oriented fiber, and the first thing, another thing, this aligned fiber. So aligned fiber is nothing but, so this is the concrete matrix, the concrete matrix. Matrix, and this is the aligned fiber. See, this is the aligned fiber. Here you can see the P load is there. So this is a tensile load. Okay. then we are giving the load in the direction of the fiber. So it directly the fiber can directly take the tensile load. So this P is divided is nothing but PM by PF. PM by PF. Okay, so PM by PF. Actually, this sigma. Um, actually, the theory says that there is no slippage between the concrete phase. This is the concrete. This is the concrete concrete matrix, and this is the fibers. These are the fibers. Okay, these are the fibers. Fibers. These are the fibers, and this is the concrete. This is the matrix. Okay, now what it says that there is no slippage condition, means the matrix get attached with the fiber, that which tells this this sigma epsilon sigma c equal to sigma f equal to sigma m. Sigma c is concrete, that is the strain is equal to the fiber and also the matrix. There's no slippage condition, no slippage. Slippage function. So what we did, so maximum this P is just distributed with the matrix and also the fiber, the PM plus PF. Okay, so sigma is this PA can be written as sigma A, and now the PM can be written as sigma M. Sigma M into M plus sigma F into F. Okay, so these are the. So if I now multiplied with the del L, so this is del L, multiply the volume. Okay, sigma A into del L, A into del L, sigma, yes, sigma M, AM del L, sigma F, AF del L. Okay, okay, what happened? Sigma F is nothing but it will just it is the volume, right? So volume. So sigma M AM delta L by volume by a sigma F delta L by volume. So this actually gives the volume fraction of the matrix sigma into VM plus sigma F equal to VF. Okay, so this is the volume fraction. This is the volume fraction of the volume fraction of the matrix. This is the volume fraction of the fiber. Okay. Yes, and similarly, as because this strain are equal, you can directly relate with this. Okay, so if we make a strain of it, out of strain of it, so how does it look like? So it is, you can calculate it. So it is like a EC is there, so E concrete is there. So it's VM EM plus VF equal to EF. Okay, so volume fraction of the fiber plus elastic modulus of the fiber, volume fraction of the matrix, elastic modulus of the matrix. So these are okay. So these are the few points. So VM, so actually VM plus VF equal to 1. You can just replace VM if VM equal to 1 minus VF. So these are the things. So now actually this. Yes, now if the short fiber is there, whenever the short fiber exists, so because of this orientation, because of this orientation and this um, orientation and this length, all fibers are not equal. There's short and long fibers. So because of this correction, because it is not taking the desired load, so it is now reduced to some efficiency factor. That this is the length efficiency factor, eta L, eta not equal to that orientation efficiency factor by sigma F Vf by sigma M 1 minus Vf. This is the this when the short fiber is at. So short fiber is, so this is relevant to this. So this is the concrete block, and the short fibers at this line, short fibers. So and here this concrete at here. So this is the this is for the randomly oriented fiber. Okay. And this NL, this says this NL, this eta L equal to half for L equal to LC. When the critical length, when the fiber length is equal to critical length, then N equal to NC. Actually, there's some derivation also there. And if it is N equal to L by twice LC, when L equal to L less than LC, and it is 1 minus, it's 1 minus LC by twice L, 1 minus LC by twice L when L greater than LC. So these are the two important things. Now the efficiency factor. Now we can discuss three possible scenario when this L greater than LC, and L equal to LC, and L less than LC. I hope the two parts is now our point of discussion. Actually, we are introducing the fiber, which has a much strength as compared to the matrix. So so actually this fiber fails. The fiber fails at a particular at a particular strain. There's the sigma mu. Okay, so the epsilon mu. So okay, so yes. Actually, what happened when the fiber actually when the matrix is strength is lower than the fiber, actually generally happen. What happened? This matrix matrix reached to its limit, and the fiber still below its strength. Strength. The fiber stays is still below its strength level. So what happened? This matrix will fail and at its ultimate strength, and then this. The sigma C, or this the sigma C, this sigma C means concrete will be taking place Vm by already you can check this volume fraction of the matrix by sigma mu, sigma mu is at the strength it is reaching, and sigma F equal to Vf with sigma F. Okay, so 1 minus Bf you can easily write by sigma mu. Okay, plus Bf, and we can easily write it the stress. Actually, the stress will be what? How much is the stress? So fiber will be strained to epsilon mu, and it has the EF, means modulus of elasticity EF. So as the fiber doesn't fail, that and it's strain up to epsilon mu. That's why the sigma F equal to epsilon mu into EF, and VF critical. Now the volume fraction of critical volume of fiber volume fraction of fiber, you can understand the what is the basic thing. The as fiber content increases with time, and fiber content increases at the but at times comes when if you increase further fiber content, there'll be yes, so at a particular time, if you increase if you increase the fiber content to a higher level, or at a time comes when the concrete the matrix doesn't take any load, and even if the matrix takes even if the matrix fail, the fiber will continue to take the load. So it is called the critical fiber volume. The critical fiber volume is the VF critical is the C epsilon mu by the sigma fu. Okay, and it can also be written as sigma mu sigma fu by this ultimate strength of the fiber, ultimate strength of the matrix minus epsilon mu EF plus sigma mu. So these are the things, and there's also some certain theory about this distance. Okay, when this L equal to LC. Okay, so what happened? This this is the fiber length. So this is the fiber length inside the concrete matrix, and this this has a fiber. The fiber strength is sigma f. Ultimate strength sigma fu. Actually, what happened? This if this concrete is filled with this entire region and fiber is here, there is no crack inside it. So what happened? It will just show this diagram. So this is the LC. So this is the LC, and this is the sigma f. Okay. Now, due to the matrix and the interaction of the matrix and fiber, the average stress will come. What is sigma average? So sigma average is okay. So sigma average will come because of this interaction of this concrete matrix and the fiber strength. However, this is the continuous fiber. See, this the continuous fiber is if it is there. So so when the L equal to LC, this is the situation. So this is triangular part is there, and when this continuous fiber is there, then fiber will be strained all along the length. So it is ultimately sigma fu for continuous fiber. Continuous fiber. Okay. So now this L equal to L greater than LC. What happened? This L is there. L is L greater than LC. Okay. So what happened? This it will shape a triangular shape. The triangle is a trapezoidal shape. This is trapezoidal shape. So you can easily find it the stress block. You can easily find the stress block, and you can find this average stress. So actually, this average stress is nothing but this 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 area of the whole block, divided by the LC. So sigma average nothing but this area of the whole block by divided will comes at sigma half sigma fu LC by LC. So these are the things, and uh, now for the this NL, what we have just told that this is length efficiency factor for short random oriented fiber. If L equal to LC, what happened? What happened? This is the L. This is L. Okay. Now what happened if it is this is L equal to LC? What happened? This NL length efficiency factor is half sigma fu by LC divided by LC. So L equal to LC divided by sigma fu. This is the efficiency factor. So this is called the half. So efficiency means this actual actual stress divided by the original stress. This is the actual stress divided by the actually existing stress. How much the existing stress is there because of this short length of the fiber? How much the stress it can carry? So this is the ratio is called the efficiency. So that's why it's just if you cross it and you can make a you can approach this half. So this is how this theory says. Now for the yes, sorry, I have told you. I think this is not correct actually. This is this half and this odd value. Actually, should have told you this way. Actually, this all you can derive. There is no difficulty in it with the stress block, and by just dividing the way I'm just showing how it comes in it equal to 1. The similar way you can do it for other cases of L less than LCL greater than LC. This all for um, aligned fibers. Aligned is all for aligned fibers. Aligned fibers. Okay, this all all valid for the aligned fibers. So you can do it on your own. Okay, so there is also we'll be doing if it is a time permits yeah, tomorrow, then we'll be doing this. Then one part I want to this if there's a crack with also there and also this is see uh, this is the concrete and this is the concrete is there and this is the crack. Some crack is here, crackers here, cracks are here. You can also design you can also find this crack width and this is the okay. So actually these cracks are 2x dash. Okay, the 2x dash and this is the matrix. These are the matrix. These are the fibers. Actually, these are the fibers. Actually, what happened? These are the fibers. What happened? This matrix. It this up to this level. This matrix just reach to the sigma mu. If epsilon mu. Actually, this is the strain. Actually, this is the strain. Strain is there. This is epsilon mu 1 plus alpha strain. This strain block is there. This is epsilon mu. Okay. So at this stage, this epsilon mu is there, and fibers also introduced. What happened after it get failed? This stress transferred to this fiber. Okay, so this stress transferred to the fiber. Actually, this is the stress strain diagram with the distance. Okay, so it's like a difficult to make it a 3D view. So actually, the excess stress that the matrix is supposed to take will be taken by the fiber. What is the excess stress? That is that is this excess strain. Actually, the excess strain is 1 plus alpha. 1 plus alpha strain is the excess strain that will be taken by uh, the fiber. Okay, so actually this delta C actually delta C, that is the that increase in strain at a point of matrix cracking. So it is actually epsilon sigma mu by 2, and alpha is nothing but EM by PM by EF by PF. So with this you can easily calculate the strain, the extra strain that that the fiber will be taking, and with that strain the excess stress are coming is sigma F into PM, the volume fraction of the fiber, sorry, this is sigma m means this the stress at the matrix level by sigma the volume fraction of the matrix divided by this EF. This tells you this tells you the how much excess this stress will be carried out by the fiber when the matrix get failed after reaching this epsilon mu, this after reaching its ultimate strength. So these are the few theories, and these are all related, and there's also derivations are there. So you just go through it. If you not understand, then we'll be discussing, and otherwise there will be some comprehensive and discussion on the MCQ questions next is tomorrow, coming tomorrow. So thank you guys. I hope you enjoyed this session. So thank you for joining.
Thank you, sir.